So I'm going to review our endotopic test on periodicity group 2 and group 7 in two parts. This is the first part looking at questions 1 through to 6. So question 1, you were asked which represents the correct order for increase in radius of the ions. Okay, so I think you guys are pretty hot on general radius trends, but when we're thinking about the ions, their shapes are going to be slightly different. So we need to realise positive ions have a smaller atomic radius for the element and negative ions are larger. And the correct answer for this one was C. Question 2, which property would you expect from the element radium to possess? And radium is a group 2 metal, so we'd expect it to be a good conductor of electricity. Question 3, in the test the halide ions in aqueous solution, dielectric nitric acid is added before the addition of silver nitrate solution. Why is it added? And the answer to this is to prevent the precipitation of silver compounds other than halides. Carbonates will produce a white precipitate and so give a false positive result in this test, so we want to get rid of that first. Question 4, which shows the major products formed when chlorine reacts with cold dilute aqueous sodium hydroxide. So we mentioned this in class, it also came up in your homework, and the answer for that was C, sodium chloride and sodium chlorate. So an aqueous solution of sodium salt gave no precipitation when treated with either silver nitrate solution or barium chloride solution. Which one of the following could be the formula of the sodium salt? So we know it's not going to be sodium iodide, and we know it's not going to be sodium bromide because we're familiar with those silver nitrate tests. And in this case it's going to be the sodium fluoride. It doesn't make any precipitate. Question 6. This question is about group 7 elements and their compounds. Chlorine is used to treat water even though it's toxic to humans. Give one reason why water is treated with chlorine. Explain why chlorine is added to water even though it's toxic. Give an equation for the reaction of chlorine with cold water. So on this question it was the emphasis for each part that we got a bit muddled on. So we were generally confident with the reason we add chlorine, that is to sterilise water, kill microorganisms, any words to that effect. And we generally knew that. Now the explanation, lots of you said, well, we sterilise it so that it's safe to drink. But actually it's asking, why do we use chlorine even though it's toxic? We know it's toxic. We want to be emphasising the health benefits outweigh the risks. Always refer that the fact that we only use such a small quantity that the risks are low would be fine too. But it's emphasising why do we use it even though it's toxic? Not why, the reason we use it, but why do we use it even though it's toxic? Then we had to give the equation. So lots of you did the top one there, chlorine plus water goes to hydrofluoric acid and the chlorate ion. But we need to have the equilibrium symbol, so if you didn't have that equilibrium symbol, you lost that mark. Or a few of you did the below question, 2Cl2 plus 2H2O forms 4HCl plus O2. Okay, question 6b. I think a few of you are going to be annoyed you didn't get as many marks as you would have liked and could have got on this one. Solid sodium iodide reacts with concentrated sulfuric acid to form iodine and sulfur in a redox reaction. Give a half equation to show the conversion of iodide ions to iodine. Give a half equation to show the conversion of sulfuric acid to sulfur. Give an overall equation for the reaction and identify one other potential sulfur-containing reduction product formed when solid sodium iodide reacts with concentrated sulfuric acid. So I'm going to show the answers first, then I'm going to go through them step by step to explain why they were the way they were. So first part says half equations for the conversion of iodide ions to iodine. So the first thing you need to recognise is that we're going from the ion to its elemental form. So we're going from the I minus to I2. Okay, we're at A level now, we've got to say I2 is a diatomic particle. Next, you need to make sure we've got the right number of ions on each side. Then we add the electrons. A few of you who did this had this the other way around, so look very carefully at the question. There are iodide to iodine. So next part we do the half equation for the conversion of sulfuric acid to sulfur. So I've written up here sulfuric acid, an arrow pointing to the sulfur. So that's our base start point. So let's look at the oxidation states of the sulfur. In the sulfuric acid, it's got a +6 oxidation state, and its elemental form on the other side is 0. So we've got a gain of 6 electrons. So I'm going to write that in and show sulfuric acid +6 electrons forming the sulfur. So now I need to sort out the charges. On the first line, both sides were neutral overall charge. If I look down my second line, I've got 6 electrons. I've got a net -6 charge on that left-hand side, and a charge of 0 on the other side. So I'm going to add some hydrogen to balance out those charges. So I've got H2SO4 +6H +6 electrons forming the sulfur. I now need to sort out, we've got these hydrogen ions and atoms, and we've also got some oxygen floating around that need to sort out, and I'm going to sort that out by adding water to the other side. And there I go, I've got my half equation for the conversion of sulfuric acid to sulfur. Now, overall equation, I'm combining these equations. Now, when we're combining half equations, we need to make sure we've got the same number of electrons on each part. So I've got 6 electrons in that first equation, second one only 2, so I'm going to triple everything in that second equation, and now I can combine them. And so if I write them all together, I've got this big long line, the electrons cancel out, so I've got an overall equation written there. So a student completes an experiment to determine the percentage by mass of sodium chloride in a mixture of sodium chloride and sodium iodide. This is the method: 600 milligrams of the mixture dissolved in water to form a solution. An excess of aqueous silver nitrate was added to the solution. This forms a precipitate containing silver chloride and silver iodide. Excess dilute ammonia solution is then added to the precipitate. The silver chloride dissolves. The silver iodide is filtered off from the solution and is washed and dried. The mass of the silver iodide obtained is 315 milligrams. Silver nitrate added to the solution suggests why an excess is used. So this is the same reason for all things that are used in excess, is to make sure everything else is fully reacted. In this case, we're making sure all the halide ions, that's chloride and iodine, are removed from the solution to ensure that the precipitate represents all the halide ions. You had to refer to those halide ions to get the mark. So now we're asked to calculate the amount in moles of silver iodide obtained. And we've got to spot here, and this is the most common mistake, that the mass was in milligrams and not grams. So we have to do that conversion to get the marks. So mole is mass divided by mR. Our mass converted is 0.315 divided by the mR which you're given to give 1.34 times 10 to the minus 3 moles. You're also asked to calculate, using your answer part D, the mass in grams of sodium iodide mixture. So given the 1-to-1 ratio, times that moles by the mR, and we get a mass of 0.201 grams. Finally, we're asked to calculate, using our answer to part E, the percentage by mass of sodium chloride in the mixture. Now I would point out, if you had no idea what assumptions or what to do for part E, you should write a number in, so I can imagine most of you being able to work out F, and some of you left it blank because you didn't have an answer to E. So in that scenario, put an answer in from E because you'll get error carried forward. Anyway, to get this mark, we'd work out the mass of sodium chloride. So that's going to be 600 minus the 201 that we've just worked out to give us 399 milligrams. Then as a percentage, 399 divided by 600, which is our total mass given in the start of the question, times by 100 to give 66.5%. So that's the end of the first video and covers question 1 to 6. The next few questions will be covered in part B.